How to quickly obtain geographic information in a disaster scene is very important for the rapid deployment rescue. You can use Matrix 30 to capture visible light or infrared images by Dji Pilot app mapping function and reconstruct visible light and infrared models by DJI Terra or DJI FlyHub 2 platforms. To perform cloud mapping, you need to log into DJI FlyHub 2. Open DJI Pilot, click Flight Route, select Create a Route, then you can see the mapping option. Within mapping function, you can delineate your mission area and set the route parameters. Then Pilot will generate a S-shaped flight route automatically. After importing the planned route into the aircraft will start to collect data. So, how to plan a mission area specifically? You can generate a mission area by adding boundary points or importing a KMZ file. This video uses the app method. Click Tap to create a mapping area to add mission area with several boundary points. Drag the boundary point to the frame of the area or click the plus sign to add boundary point. You can also generate boundary points by entering their longitude and latitude. Delete button can delete the selected boundary points, and Clear button allows you to delete all the boundary points. You can switch the map to satellite images using the Map Switch button, and you can select the base map source in Common Settings. Set mission parameters. After the mission area is set, you can rename the mission, and mission name will also be used as the file name of the data storage, so that the mission data can be found after mission is completed. In Select Camera Interface, select Matrix 30, which has 3 shooting methods: wide, IR, and wide plus IR. Refers to the wide-angle, infrared, and wide-angle plus infrared camera. Wide-angle camera can capture visible light photos and be used for 2-dimensional map reconstruction. When it's 100 meters away, the GSD is 3.56 centimeters per pix. Select IR to capture infrared images, which can be used for reconstruction of infrared models. When it's 100 meters away, the GSD is 13.19 centimeters per pix. When Wide plus IR is selected, the GSD data of the infrared camera is displayed. After selecting camera, the flight route is generated based on default parameters. By enabling cloud mapping, you can complete real-time reconstruction of the DJI FlyHub 2 cloud platform. When the mission area is heavily undulating, the terrain follow function can be used. After importing the DSM file, the aircraft can fly up and down along the undulating terrain, always maintaining a fixed shooting distance from ground. When using terrain follow function, it is recommended to enable the RTK function. On Select DSM File page, select the desired DSM file. There are 2 ways to acquire DSM files. The first method is to obtain the 2D data of the measurement area and modeling them through DJI Terra. Among all generated modeling files, the GSDDSM.TIFF file can be used as an elevation reference for the terrain follow flight. It can be copied to the microSD card of the remote controller. The second way is to download the public terrain file and copy it to the remote controller's microSD card. Please note, only DSM files with geographic coordinate systems can be recognized by Pilot 2. Meanwhile, the resolution of importing data is recommended to be less than 10 meters. After importing the data successfully, you can plan tasks in the imported area and generate terrain follow flight routes. Tap adding or subtracting buttons to the set of the terrain follow height or enter the altitude value directly. When flying without terrain follow, ASL-ALT menu will appear. ASL-ALT menu includes relative to the takeoff point and ASL, which determines the datum for calculating route altitude. The route altitude in the relative to takeoff point mode indicates the flight height from the takeoff point to the aircraft when the aircraft is operating. The route altitude in ASL mode refers to the altitude of the aircraft relative to the droid of EGM-96. When performing aerophotogrammetry work, the relative to the takeoff point mode is generally selected. Target surface to the takeoff point option appears in relative to takeoff point mode. The height of the target surface to takeoff point is the height of the target surface minus the height of the takeoff point. For example, if you take off the aircraft from the roof of a building of 10 meters high above the target surface, you need to set the height of the target surface to takeoff point to minus 10 meters. When ASL is selected, the flight route altitude option appears, which is the height of the flight route minus the height of the target surface. We use this height to calculate the GSG value. Takeoff speed is the flight speed of the aircraft reaching assigned height of the route, but not entering the route. It is not the speed at which the aircraft takes off vertically. It can be set to the maximum to improve the operation efficiently. Speed is the operating speed of the aircraft during the route, and the maximum speed is related to the GSG and frontal overlap ratio. Elevation optimization means that when the mission ends, the aircraft will fly towards the center of the mission area and continue to take a set of oblique photos to optimize the accuracy of the elevation data, which is applied to the elevation accuracy needed scenarios. Upon completion is the flight action when the aircraft has completed the mission. It includes 4 options: exit task, return to home, land, return to start point, and hover. The default option is return to home. Select return to home. The aircraft will return to the home point after completing the mission. If you choose exit task, the aircraft will hover at the last waypoint after completing the operation, waiting for your next command. Return to home is recommended when takeoff and landing are at the same location. You can choose exit task mode if you follow the aircraft. Advanced settings. In advanced settings, the side overlap ratio is the overlap ratio of photos on 2 adjacent routes, and the frontal overlap ratio is the overlap ratio of photos on a single route. Overlap ratio is one of the key factors affecting the success of the reconstruction. The default side overlap ratio is 70% and the frontal overlap ratio is 80% in DJI Pilot app, which are suitable for most application scenarios when shooting with a wide-angle camera. If the mission area is flat, the overlap ratio can be appropriately reduced. For example, set the side overlap ratio by 60% and the frontal overlap ratio by 70% to improve efficiency. If the task area fluctuates greatly, it is recommended to increase the overlap rate. For example, set the side overlap ratio by 90% and the frontal overlap ratio by 90% to ensure the reconstruction accuracy. When shooting with IR or IR plus wide camera, it is recommended to set the side overlap ratio to 70% and the frontal overlap ratio to 80%. By changing the course angle in advanced settings, you can adjust the direction of the route and the start and end position of the route. Please note that the direction of the route affects the time it takes to complete the mission. Generally, the expected mission time is the shortest under the default course angle. Margin is the radius of a buffer of measurement area, which ensures the result's accuracy of the measurement area's edge by shooting the outside area. Photo mode includes time interval shot and distance interval shot. Time interval shot is used to take a continuous series of photographs at each specified time interval. Distance interval shot is used to take a continuous series of photographs at each specified distance interval. It is recommended to select distance interval shot mode when executing mapping mission. When the parameter setting is done, save the task. Pre-flight check. You need to find an open space to start your flight mission. The ground of takeoff point should be flat and clean. Make sure there is no small pebbles, plastic bags, and other debris. Expand and power the aircraft. Retrieve the task in the DJI Pilot app and click Upload Flight Mission. In Pre-Flight Check menu, check the parameters of the aircraft and the status of the UAV health management system and confirm that everything is working properly. Exit the HMS module. Make sure the remote controller is in N mode, the aircraft and the remote controller receive enough power, and the positioning information is normal. If the RTK solution is needed, the RTK status should be fixed before starting to work. Make sure the SD card has enough space for this task. If not, it is necessary to replace or format it. RTH altitude and max altitude need to be higher than the flight route altitude. The home point setting is determined by actual situation. If the takeoff and landing position is changed, it is recommended to update the home point. Out of control action is the losing control behavior when the aircraft is not executing the flight mission. You can choose hover, land, and return to home. The default option is return to home. If you turn on max flight distance, you need to make sure the distance between the furthest waypoint and the home point is less than your max flight distance. Select your control stick mode based on the actual situation. The default mode is Mode 2. In scenarios with strong winds or the batteries have large number of cycle counts, it is recommended to increase the power alarm values of customized battery warning. When there are many objects around the takeoff or landing site, the obstacle sensing settings can be adjusted to ensure a smooth takeoff process. Click Next, confirm the route length, estimated operation time, number of waypoints, and photos taken. Confirm whether Save Photo setting correctly, and check out the Reconstruction GST. If you choose to shoot with wide angle and infrared camera at the same time, the GST shows the IR camera's value. Check RTK status. Upon completion, actions include exit task, return to home, land, return to start point, and hover. The default option is return to home. Out of control action is the action performed after the aircraft is out of control, including hover, land, return to home, and continue. The default selection is continue. Created folder is where the capture photos are stored. The default file name is the task name, which can be modified. Camera mode includes auto, automatic exposure, and M, manual exposure. It is recommended to use auto in well-lit scenes, and manual exposure can be used in low-light scenes. When you choose M, you can adjust the shutter speed to ensure the shooting effect. After checking all flight route parameters, click the Upload Flight Mission button to start the task. During flight execution, pay attention to the aircraft's battery level, image exposure, and the remaining space of SD cards. Switch to the FPV screen, observe whether there are any obstacles in front of the aircraft, and click Route Progress to monitor the map's construction progress in real time. The real-time mapping results can be viewed on the web page and the APP. If one sortie falls to complete the mission, the aircraft will record the location of the interruption, and after the battery is replaced, the aircraft can continue to operate from the point of interruption. After the mission is completed, check the status of the aircraft first, then copy and import the mission data into DJI Terra, and you can generate a 2D visible light or infrared orthophotos. Thanks for watching!